Hello everyone and welcome to a new lecture. So in this video we're going to talk about infinite limits. In the previous lectures we talked about limits at infinity. As x approaches positive infinity or negative infinity, what happens to our function, or what is the behavior of f of x? Okay, meaning x will not get larger and larger and larger or smaller and smaller and smaller, but x will approach one particular value and we will see what happens to the function, or what is the behavior of the function. Okay, that is basically what infinite limits mean. Okay, so suppose we have a function f of x to equal to 1 over x minus 1. Okay, and I'm asking you to find me the limit as x approaches 1 of f of x. Okay, what is the behavior of the function, or what does the function approaches as I get closer and closer to x equaling to 1? Well, you know, for this particular function, if I put 1 inside this function, I'll get 1 over 1 minus 1. 1 over 1 minus 1 will be 1 over 0, and that is nothing. So I'll not get a defined thing. Therefore, we're going to use the limit to see what is the behavior of the function around x. As x gets closer and closer to 1 from the right-hand side or from the left-hand side. Okay, and I can create a table for that. So suppose this is x and this is f of x. Okay, so as x gets closer and closer to 1, so suppose not 1 but something close to 1 from the right hand side. So if this is 1, I get closer and closer to 1, my x values. So suppose 1.1. So if I plug in 1.1 inside the function, I'll get 1.1 minus 1 and I'll get 0.1. Okay, so I'll have 1 over 0.1, which is 10. Okay, so at x equaling to 1.1, my f of x equals to 10. Okay, suppose I get closer. So instead of having 1.1, I have 1.01. Okay, I get closer and closer to 1 from the right hand side. Well, if I plug in 1.01 into this function, it will be 1.01 minus 1, so it will be 0.01 underneath. 1 over 0.01, basically it is 100 over 1. So I get 100 right here. Okay? And if I plug in 1.001, I'm going to get 1,000. If I plug in 1.0001, I'll get 10,000, and so forth. So it seems like as I get closer and closer to 1, okay, my f of x gets larger and larger and larger. Basically, it goes toward positive infinity. Okay, and the same goes for negative values. So if all these become negative, my f of x's will become negative, and they will go toward negative infinity. So as I get closer and closer to 1, or the limit of this function as x gets closer to 1, it seems like to go toward positive and negative infinity depending on what direction you are approaching x. If you are approaching x from the right hand side, you'll go toward positive infinity. If you approach it from the left hand side, you'll go toward negative infinity. So on this side you'll go toward negative infinity, on this side you'll go toward positive infinity. So the limit of this function, okay, depending on what direction you are going to, it will be positive or negative infinity. Okay, so that is an example of infinite limit. Your function, as x approaches a particular value, goes toward positive or negative infinity, or it can go toward only positive infinity or only negative infinity. That is infinite limit. As your x gets closer and closer to a particular value, your y values go toward infinity or negative infinity. Okay, so if you graph this, so suppose this is x equaling to 1. This is x equaling to 1. As I get closer and closer to x, let's say from the right hand side, my y values go toward positive infinity. So as I get closer and closer to x, my y values go toward positive infinity. And as I get closer and closer to x from the left hand side, my y values go toward negative infinity. So basically, we have a behavior that looks like that. And what does this remind you of? Well, this is a vertical asymptote. we will have a vertical asymptote right here. And that is basically a rule. Okay, it says that for a particular function, if you have the limit of the function as x approaches a particular value, so for right here, t approaches 1, and the limit of that function gives you either positive infinity or negative infinity, then for that particular value, okay, such that x approaches it, that particular value will be a vertical asymptote. So right here, for example, the limit of this function as x approaches 1, value right here is 1, the limit of this function goes toward either positive infinity or negative infinity. Since we have either positive infinity or negative infinity, meaning since we have infinite limit, then for that particular value that caused that particular value is a vertical asymptote. And actually this function at x equaling to 1, we have a vertical asymptote. Okay, so that is what infinite limits are used for. You can use it in order to find vertical asymptote. Okay, so let me just repeat it again. For a particular function, if you find the limit of it as x approaches a particular value and the result of it either is positive infinity or negative infinity, then for that particular value that x approaches, okay, such that the limit of it gives you either positive or negative infinity, that particular value is a vertical asymptote. Okay, so let's look at this on Dismos. So we have 1 over x minus 1. Okay, so as you can see, and let's have x equaling to 1 to be a line. So right here, okay, this is x equaling to 2.12. As I get closer and closer to 1, so right here is 1.6, I get closer and closer to 1, x equaling to 1, watch my y values. Well, my y values get closer and closer and closer, or they go toward infinity. Okay, they never cross the vertical line x equaling to 1. That is basically the definition of vertical asymptote. So the limit of this function as x approaches 1 from the right hand side is infinity. And the limit of it as x approaches 1 from the left hand side is negative infinity. Since we have that result and the cause of it is x approaches 1, 1 is the value, then that particular value is a vertical asymptote. Right here the function has a vertical asymptote at x equaling to 1. No matter where you go, the red line will never cross the blue line. Okay? So let's go back to the drawing boards and let's solve a problem. Suppose I want you to find the limit as x approaches 3 of 1 over x to the 2 minus 9. Okay? See what is the limit of this function as x approaches 3 and see if we have vertical asymptotes. Well, just think about it. So the limit as x approaches 3 from the right hand side of 1 over x to the 2 minus 9. Okay, if we want to know what is the behavior of this function as x gets closer and closer to 3, okay, you can, so this is 3. As I get closer and closer to 3, so suppose first of all I start at 4 and then at 3.5 and then at 3.4, 3.3, 3.2, 3.1, 3.01, 3.00001. As I get closer and closer to 3 from the right hand side, what happens to this? Well, when I plug in those values right here, I always get a number that is greater than 9. Okay, so suppose I plug in 4 right here. 4 squared is 16. 16 minus 9 is 7. 1 over 7 is a particular value, but 1 over 7 is smaller than, okay, if I plug in, let's say, 3.5. 3.5 squared minus 9, 1 over that will be a larger value. So as I get closer and closer to 3, this function gets bigger and bigger and bigger. Basically, it goes toward positive infinity. Okay, so the limit of this function as x approaches 3 from the right hand side basically equals to positive infinity. And if you approach it from the left hand side, so the limit as x approaches 3 from the left hand side of 1 over x to the 2 minus 9 equals to negative infinity. And the reason is, so this is 3. Suppose you start from 2.9 and then 2.999 and then 2.99999. Okay? Whatever value that you have and you plug in into this x to the 2, it will give you a value that is less than this 9. That value minus 9, it will give you a negative value. And the closer you are, the smaller this becomes. Okay, so 1 over a small value, it's a large value. And the smaller it is, the larger this value is. However, you have a negative right here. So basically, you go toward negative infinity. And you can look at this most, okay? Plot this function 1 over x to the 2 minus 9, and look at the behavior of function as x approaches 3 from the right-hand side. See, your function goes toward infinity, okay? So for this particular function, it seems like at x equaling to 3, we have vertical asymptote. But that is not the only asymptote that we have. At x equaling to minus 3, we also have a vertical asymptote, because minus 3, if you plug it right here, it will be 9. 9 minus 9, it will be 0, and it will give you a defined thing right here. So at x equaling to minus 3 and 3, we have a vertical asymptote. Since the limit of this function as x approaches minus 3 and 3, from right hand side and from left hand side, either you go toward positive infinity or negative infinity. So if we have a negative right here, meaning as I approach minus 3 from the right hand side, so if this is negative 3, something that is greater than negative 3 is, let's say, negative 2.9. If you plug it in right here, it will be positive, but when you square it, it will give you a value that is less than 9. So it will give you a negative value, and the closer you get to 3, the smaller the value that you get as a result of this operation. So basically, you will get values that are negative, and they get smaller and smaller and smaller. So they go toward negative infinity. But this one goes toward positive infinity, and for that, you figured it out. Okay? So that is basically what infinite limits are. They help you to find vertical asymptote, and they are those values such that the limit of the function as x approaches those values goes toward either positive infinity or negative infinity. And with this, we come to the end of this lecture.